All right, gonna give out the syllabus. This is my first time teaching this particular class, so, well, second time today, but first semester teaching this class. So, have to bear with me, I'm not completely familiar with how the previous instructor did it, and I've been working on trying to learn how to use the WebAssign and integrate it with Canvas, that sort of thing. There you go. But just as a kind of a disclaimer, this is kind of a math class, is basically what this class amounts to. Not a big secret. I've told many people this. I don't like math classes. I'm not going to take it out on you guys. But what I don't like about math classes is the way they're taught. Too much abstract, not enough application. That bugs the heck out of me. So I generally don't like math classes. So I'm going to try to teach this class in a way that that I see that math could be taught. Not necessarily should be taught. It just, everybody has their own way of learning. So I'm going to try to bring as much application into this class as possible, so you not only learn the abstract ideas, but where and when to use them. All right. Like I said, this is Discrete Structures. My name is Mr. Overton. I'm an adjunct professor, which means I'm part-time. I'm not here, 40 hours a week, not typically. But I am here more than most adjuncts are. I try to be available as much as I can for the students. That's why I'm here, is teaching and helping students and that sort of thing. So, what are we going to be covering in this class? Functions, sets, relations, proof techniques, propositional and predicate logic, counting, and a variety of other stuff. Basically, I've come to the conclusion that this class formalizes common sense. Mathematically formalizes common sense. I mean, we've all been counting since we were knee-high to a grasshopper, so we know what counting is. But counting really large numbers and counting more quickly and that sort of thing is going to be covered. We've been using variables since pre-algebra. The first section that we're going to cover today is about variables. What does a variable actually mean? What formally, mathematically formally, what does a variable mean? That sort of thing. It's just formalizing, like I said, stuff that we already know intuitively or from previous classes that we've taken. I repeat this till I'm blue in the face. Don't overthink things. This abstract thoughts, concepts and stuff that we're going to cover in class are not that complicated. Just because we're formalizing it doesn't make it any more complicated. The formal definition of and, okay, it still means and. It just, in math, what does that mean? What does that translate to? It's just putting solid definitions, unambiguous definitions, to concepts that, like I said, are pretty much common sense to most everybody in the room here. So it's going to be just formalizing common sense. Don't overthink it. You know, if it's something that looks easy, maybe it is easy, you know, but keep it simple, silly. The KISS principle, you know, keep it simple. What you need to know. You should take notes. Take notes. I hound on this topic just about every semester. Notes are an important thing. That they help you assimilate information. Ask questions. I would say that the only stupid question is the question that is never asked, but that is not true. Just a little story. I was in a supermarket one day and was by the sodas, and this lady walked up to me, straight face, asked me, "How many are there in a 12-pack?" Okay, the question that answers itself might be considered a stupid question. Other than that, fair game. So if the question doesn't answer itself, go ahead and ask it. No big deal. I'm here to answer questions. Other folks might have the same question, and you just need to be the one to speak up on it. You know, communicate with me. If there's a problem, see me after class. See me in my office. Just let me know. If you're going to miss class for some reason, let me know so I can work with you and keep you up to speed and keep you current on what's going on in class. If you don't tell me what's going on, I'm just saying, just seeing people not attend class, you know, okay, they don't want a decent grade. You know, I don't want to flunk anybody, but I have flunked people in the past because they didn't show up, they didn't do their work, and they didn't offer any explanation. Yeah. So communicate with me. I'm here and willing to listen. Now I will allow notes on quizzes and tests. A professor of mine, when I was an undergrad, put it to us this way. He didn't know of any job in this field that didn't allow you to have reference material. When you get out into the workforce, you're not expected to memorize everything. There's just way too much information. So, in keeping with that, with the spirit of that, I allow handwritten notes to be used on quizzes and tests. Not open note, not open internet, but handwritten notes. Or if you take notes on a tablet, you can print those out and use those. But yeah, allowing notes on quizzes and tests. Also, I will video record the classes, the lectures. As you can see, I have my camera over there. And I record all my lectures in case somebody who has a legitimate reason for missing class needs to catch up on things. They can go on YouTube the next day and watch the lecture. I have a person with the JSU Gmail accounts. We can't have YouTube channels, but I have a personal YouTube channel that will have a playlist for discrete structures. It'll have the lectures for both the section 1, which is the hour and a half before this class, and section 2, this class. So I record both lectures. If I didn't explain something in a way that you understand in one lecture, maybe I did in the other lecture, and you can watch that video and that sort of thing. But generally, the videos are uploaded the day, the afternoon of, or the day after the lecture. Probably more likely the day after the lecture. So, so I'm wearing a lavalier mic. I will be clear on, and the audio will be clear on the video recording, regardless of where I'm at in the room. So I will record the classes. I will be available outside of class. I may be a part-time professor, but I also work on research projects on campus. So I'm here whether I'm teaching or not. I only teach on Tuesdays and Thursdays, but I'm here Monday, Wednesday, and Friday as well. So anytime you need to talk or something like that, come up to my office. Generally, it works that if I'm in my office and not on a meeting or something like that, my door is going to be open. If the door is closed but the light is on, I may not be in my office, but I am on campus. If the door is closed and the light's off, I'm not on campus. So that's kind of the code for my office. If you look at the syllabus, my office hours officially are noon to 1:30 Tuesdays and Thursdays, but I'm available much more than that throughout the week. Seemed like there was something else I was going to say, but slipped my mind. What makes up your grade? Attendance, I believe, is important, so it makes up 10% of your grade. If you have an excuse, an official excuse, you can miss class. If you are sick or something like that, I can work with you on that. But that's 10%. Another 10% is in the form of quizzes. I am working on developing quizzes and stuff like that to administer through the course of the semester. But it's not a big chunk of your grade. Homework assignments are going to be 20% of the grade. There's going to be a bit of homework. There's going to be there's going to be homework assignments every week. So that's going to be 20%. And 60% of your grade is for class exams. There's going to be 4 exams, a midterm final, and 2 extra exams. That's going to be 60%, the lion's share of your grade for this class. Like I said, homework will be assigned on a weekly basis. Homework assigned this week will be due next Thursday. So you have, at least, 2 or 3 days to get it done. I'm going to try not to overwhelm you with homework, but generally there are 3 different ways people learn: visually, audially, and kinesthetically. Visual and auditory is going to be taken care of in the lectures. The kinesthetic, the hands-on, you might say, is the homework. Having to do the homework, doing it yourself, working out the problems yourself, helps reinforce what you've learned in the lectures. But yeah, it's starting next Thursday. Every Thursday before class, homework will be due. All right, what should you be doing this semester? Again, attending class. There's no substitute for it. It's the primary opportunity for you to ask questions. If you don't attend class, and you're probably not going to get a very good grade. Not just from the attendance grade in the class, but just from not being around to get the information and being able to ask questions and that sort of thing. If you must miss class, like I said, communicate with me. I'll work with you. I only recognize one name in the class, so I don't believe I've had anybody else in a class before. But I am willing to work with you. I'm not here to flunk people. I'm here to educate people. So please communicate with me, and we can make sure you get things taken care of. Take notes. Taking notes helps you absorb the material. You have to translate what you're hearing and seeing on the screen into thoughts that make sense to you. That's what taking notes does. So if you're like me, I'm a very visual learner. I hear something, I forget it. It's gone. But if I write it down as I'm hearing it, I'm processing it, and it's getting in there, and then I see it on the page. I mean, there were times when I would take notes in class, throw them in the garbage on the way out the door, because I got it. Because I made it visual, made it suitable for my way of learning, and didn't need the notes. You need to ask questions. If I don't explain something the way you understand it, I'm not going to know that unless you say something. I won't repeat myself. I will try to reword it so that you do understand it. There's, as we're going to see in this first lecture on variables, there's lots of ways of expressing things. One way may not sink in for you, so I'll try to find another way and have it sink in. So it will sink in. So ask questions. Why is it important to take notes? Like I said, the processing of it. Oh, and the organization. When you're able to use notes as a reference, like on tests and quizzes, or while you're doing the homework, how you organize your notes is unique to you. How one person organizes her notes, how he organized his notes, may be totally different. But the important thing is that they make sense to them, so they can make quick reference to the material presented in class. And when we have tests and such, that time factor might be important. So don't just not take notes and then day before a test, ask a classmate, "Can I copy your notes?" You know, you don't know what's in there. You don't know how it's organized. One person may have skipped something. It's like, okay, I know that. I don't need to write that down. Whereas you may have to write that down for you. So everybody's different. Everybody, the way they take notes is different. Take your own notes and organize them in ways that make sense to you. What I will do this semester, allow notes. Like I said, they're going to be allowed on tests and quizzes. Not open book, but open note. So I have the calculators will also be allowed, but I don't think calculators are going to be needed for this class. So that's kind of I adapted these slides from a previous class that I had done. I will record the lectures, like I said, be available on YouTube. I will, when the video gets uploaded to YouTube, I will send out an announcement on Canvas with the link. So all you have to do is click the link, and it'll take you right to the video. I'll have a playlist for this class. And I will be available. Helping students is a priority. Like I said, my job is to educate students, not flunk them. I'm not here to make your life hard. Not that learning everything is easy, but I'm not a sadist. I don't like torturing people. Nothing like that. I'm usually on campus Monday through Friday. And if I'm not in class, which is just 1:30 to 4:30 on Tuesdays and Thursdays, I'm generally available for help. So I am understanding of special circumstances. If you need special accommodations, let me know. Do we have any athletes? Got one? Okay. Anybody in band? Got another one? Okay. I understand that athletics, people have athletic scholarships. You got to take care of the responsibilities that pay the bills. I understand that. So, got to miss class, need some extra time because you're busy with band or your sporting event. That's not a problem. I don't mind at all. Like I said, you got to go where the money is, as far as paying the bills for school and all that sort of thing. So, not a problem. Disabilities, same way. Student organizations, travel to conference, interviews. If you have an interview and it conflicts with the class, keep the interview. You can make up class. If you miss an interview, you're not getting the job, and you may not be able to reschedule. So if it's a choice between an interview and class, take the interview. Go with the interview. Travel to conferences. I don't know if anybody here is involved with any research or anything like that, or planning on going to. I think Bea is coming up soon, or whatever. Those are good networking opportunities and all that sort of stuff. So, by all means, go. We'll catch you up when you get back. I myself am going to a conference in March, so I will not be in class, but I'm going to see if I can do the lectures remotely using the big blue button thing on Canvas. But we'll work out the details on that as the time gets closer. But yeah, special circumstances, I understand. No big deal. Just let me know. If you don't let me know, I can't do anything about it. Any questions about how I'm planning on handling the class? I'm fairly easy to get along with. I'm some professors, not all, like to do research and just put up with teaching. I like teaching. I enjoy it. It's fun for me. So, I don't want to. I don't see this as being really complicated stuff that needs to do, extreme mental gymnastics to, solve these problems and that sort of thing. But I'd like you to enjoy your time in the class, and get something out of it so that you can, move forward with your education and that sort of thing. But yeah, I'm here for the students, and because of that, I have my office hours and my email. The phone number is my cell phone, so if you go by my office and the light's on, but I'm not home, I'm on campus somewhere, you can call or text me. Don't abuse the privilege. But you can call or text me, and I can meet up with you and help you out. Arrange a time for that. Like I said, the office hours that's the official office hours, but I'm here much more than that, regardless of that. So, yeah, that's my opening spiel. Let me go. Let's see here. We can go ahead and start the material for the class. If you want to get out the notepad and all that sort of stuff. I almost forgot. Let me kick out of this. We need to look at, let's see, vision view, dashboard, discrete structures, and you as a student. You should have this on your Canvas. Has anybody been on Canvas today and looked at your classes yet? You should be able to access the WebAssign registration and access link. Go to the Cengage website and such, and get registered and get the ebook. I think is included with this course. Has anybody gone to the WebAssign registration? Not yet. Okay. Well, I think you can get the ebook through that. They're supposed to be sending me a physical copy of the book, but that hasn't arrived yet. But anyway, the first 4 homework assignments, don't be intimidated by the number of assignments there are. They're range from 3 to 8 questions each, so it's not a whole lot. But those 4 assignments are going to be due next Thursday. So we'll cover all that material between now and next Tuesday. So those assignments will be available for you. Okay, back to the slideshow. Okay. If you're going to mathematically formalize things, you need to be able to speak mathematically. So that's what chapter 1 is going to be all about. The first section is on variables. Now, we've been using variables since what, pre-algebra, when they started introducing variables. So what was that, 6th, 7th grade, 8th grade, somewhere around there? I don't know, it's been a while. But yeah, using variables is pretty much second nature to us by now. This formalizes the definition of what a variable is and can do. The first way that you could use it is it has one or more values, but you don't know what they are. So you substitute a variable for that and do manipulations around that unknown value. Or you want whatever you say to be equally true for all elements, all values within a given set of possible values. So you don't get restricted and only consider one particular concrete value for it. So the first use, the question, is there a number with the following property? Doubling it and adding 3 gives the same result as squaring it. This sentence introduces you can introduce a variable to replace the potentially ambiguous word it. What is it? You don't know. But when you ask the question. So, is there a number x with the property that 2x plus 3 equals x squared? So, the advantage of using a variable is that it allows you to give a temporary name to what you're seeking so that you can perform concrete manipulations or computations with it. So, you're not stuck with a particular value. You can, or you don't know what the value is when you're doing your manipulations, mathematical manipulations, until the end. And there you go. You get the value for x, and you can assign a concrete value to it. Talking about it being a placeholder, think about it as being a box, a box to hold something, kind of like a variable in a computer program. Variables in computer programs are just memory locations that hold information. Hold the value that you may need at a later time. The empty box is the metaphor there. The second use of variables, when you want something to apply to all to all members of a set of values, is the example they give is no matter what number might be chosen, if it is greater than 2, then its square is greater than 4. So all real values, all real numbers greater than 2 are in the set of what is being considered here. So you can say that x, if n is greater than 2, no matter what n might be chosen, if n is greater than 2, then n squared is greater than 4. See this? See how I was saying this is kind of mathematically formalizing common sense? Yeah, this is kind of gimme stuff. Yeah. It gives examples of writing sentences using variables. Are there numbers with a property that the sum of their squares equals the square of their sum? Given any real number, its square is non-negative. Use variables for those numbers. Is with A though, you're dealing with 2 numbers. So yeah. I'm sorry? Yeah, I'm going to post the slide decks to Canvas after each lecture. So hopefully this afternoon, possibly tomorrow, first thing tomorrow morning. A, like I said, is dealing with 2 numbers, so you have 2 variables. And they may or may not be equal. So a squared plus b squared equals a plus b quantity squared. And like I was saying earlier about different ways of expressing things, A is answered in 3 different ways here. B is answered 3 different ways. The English language can be very ambiguous and flexible, which is why we don't program in English. We program in computer languages that are unambiguous, very clear and concise, and this means one thing and one thing only. With English, you can express things in lots of different ways. Some important kinds of mathematical statements. The most important kinds of statements, sentences in mathematics are universal, conditional, and existential statements. Okay? Universal statements, the definition is a certain property is true for all elements in a set. That's a universal statement. A conditional statement, if one thing is true, then some other thing also has to be true. Like, if a number is divisible by 4, then it's also divisible by 2. If one condition is true, or one thing is true, then the next thing is true. A property that may or may not be true would fall into an existential statement. So it says that there's at least one thing for which the property is true. Like, there is a prime number that is even. The number 2. You just have to show one example of it to be true. There exists at least one. So one prime number that is even. Now you can combine these to make various compound statements like universal conditional statements. Universal conditional statements contain some variation of the words for every, and conditional statements containing versions of the words if then. it's both universal and conditional. So, like for every animal A, if A is a dog, then A is a mammal. It's universal because for every animal is universal, and if A is a dog, then A is a mammal, is a conditional. So it's a compound statement. You can rewrite these in ways that makes the emphasize the conditional nature of the statement. Like if A is a dog, then A is a mammal. They can also be expressed so the universal nature is more explicit. For every dog A is a mammal. So the conditional nature is implicit at that point, whereas it's more universal. So, examples. Fill in the blanks to rewrite the following statement. For every real number x, if x is non-zero, then x squared is positive. Okay? If a real number is non-zero, then its square is positive. That's just what the original statement says. For every non-zero real number x, x squared is greater than 0. If x is greater than 0, then x squared is if x does not equal 0, then x squared is greater than 0. And so forth. Just different ways of expressing the same thing. But we'll get into later on how to express these types of statements mathematically with mathematical symbols and that sort of thing. But these are the solutions to the example. Universal existential statements, another kind of compound statement. A universal existential statement is a statement that is universal because its first part says that a certain property is true for all objects of a given type, and it is existential because its second part asserts the existence of something. So every real number has an additive inverse. So every real number makes it universal, has an additive inverse, asserts the existence of something, that then the additive inverse exists. The nature of the additive inverse depends on the real number, so different real numbers have different additive inverses. Knowing that an additive inverse is a real number, you can rewrite the statement in some more or less formal ways. For every real number r, there's an additive inverse for r. Or you can introduce another variable. For every real number r, there's a real number s such that s is an additive inverse of for r. These examples they're giving are fairly simple and kind of obvious to anybody that's taken at least Cal 1, like everybody here should have. But when you get into more complex formulas and processes and that sort of thing, variables and breaking these statements down can be very important and make life, it can be very important and make life a whole lot easier. My brother was telling me once when he was an undergrad, he was working on a research project. The primary formula that they were trying to prove was accurate, written in 12-point font, single-spaced on, regular sized paper. It was like a page and a half. That was the formula that they had to prove was correct and proper. So making things, breaking things down into variables and looking at the various conditions and universality or existence of different things can help you get through even those large, difficult types of problems. Universal existential statement. Fill in the blanks to rewrite the following statement. Every pot has a lid. All pots have lids. For every pot P, there is a lid L. For every pot P, there is a lid L such that L is P's lid. Like I said, there's so many different ways of writing the same thing. I don't know how other languages are necessarily, but English can be very confusing in that regard, and how many different ways you can express one thought. English is more of a mishmash of other languages than most other languages, so that probably plays a factor in the evolution of the language. But neither here nor there. Something for the liberal arts department. Existential universal statements. An existential universal statement is a statement that is existential because its first part asserts that a certain object exists, and is universal because its second part says that the object satisfies a certain property for all things of a certain kind. That's a mouthful. There is a positive integer that is less than or equal to every positive integer. Okay. It's true because the number 1 is a positive integer and it satisfies the property of being less than or equal to every positive integer. But it's existential, there exists, and universal because it has it's in comparison to every positive integer. So universality there. Again, rewriting the statement in several different ways. Positive integer m that is less than or equal to every positive integer. There's a positive integer m such that every positive integer is greater than or equal to m. And then introducing the n variable. There's a positive integer m with the property that for every positive integer n, m is less than or equal to n. Several different ways of doing it. Oops, yeah. Gives an example of there's a person in my class who is at least as old as every person in my class. Basically, somebody's the oldest in the class. So there's some person that is at least as old as every other person. There's a person P in the class such that P is older than everyone, at least as old as everyone in the class. That sort of thing. and introducing the Q variable. Person P in my class with the property that for every person Q in my class, P is older than Q, or at least as old as Q. So, different ways of expressing it. This isn't, unlike most math classes, they like to have you have one solid, concrete answer at the end. In some of these examples, there's lots of different ways of expressing it. So, grading is a little bit harder, but it's you can. There's some flexibility as to how you express mathematical concepts. Some of the most important mathematical concepts, such as the definition of limit of a sequence, can only be defined using phrases that are universal, existential, and conditional. And they require the use of all three phrases: for every, there is, and if then. Anybody remember the formal definition of a limit from Cal 1? No? Yeah, it's one of those little pieces of thing that's helpful to when you're learning how to create a derivative, but after that, it just kind of slips away. But there it is. Yeah, you remember that now? Yeah, it's familiar. Yeah, but it's for every positive real number epsilon, there is an integer capital M, n, that such that for every integer n, if n is greater than lowercase n is greater than uppercase n, then that equation, that inequality. So, yeah, it's a little. I liken these basic concepts to bricks, or like the statements of a computer program to bricks. These concepts are simple and elemental, like a brick that you would use to build a house or something like that. A brick is a very basic, simple shape, right? But look at what architects have been doing with bricks for thousands of years, making all these complex, elaborate things. So you take these basic, elemental concepts and bring them together in arbitrarily complex manners to create computer programs or mathematical concepts or what have you. But when you get right down to it, it's still just those simple bricks. How many of you folks have taken computer organization? Just a couple of you? Okay. Taking it now? Are you taking it now? Oh, okay. But you get right down to it, a computer only knows addition, right? Subtraction is adding a negative number. Multiplication is repeated addition. And division is repeated subtraction. So everything's addition. Everything's that basic concept. So, but look at what computers do, what we have computers do all the time, all the elaborate things that they do, because those basic concepts get built up and all that sort of thing. Like building blocks. Anybody here like Legos when they were young? I did. I love Legos. Yeah. Build a toy and get bored with it, take it apart, build another one. But anyway, Well, that's about it for the slideshow.